Hey Calc students, this is online notes for Riemann sums, section 3.2. And today this is something we've covered in class, but some of you weren't here, and I just want to have the notes for the entire packet because I'm not going to do this in class. We have to move on to new material, and so this is just one of the things that you'll do on the side in your own time. But I do want to provide you the notes at least by video. Okay, so in this problem, it asks us to approximate the area under the curve for a function f of x equals negative x squared plus x plus 7 on 1 to 3 using a left, right, and midpoint Riemann sum for 4 intervals. So there's a lot in that, and I just want to unpack it a little bit. First thing I want to say is that we need to approximate an area under the curve, and the curve, this is the curve right here, f of x, and here's a pretty important part, on 1 to 3. So what it's saying is basically it wants us to approximate the area from 1 all the way to 3. This is our domain right here. Okay, so it wants us to find the area of this under this curve, so it's kind of this shape I'm outlining right here. Okay, now they want us to not find the exact value but approximate it, and they want us to do it with this thing called a Riemann sum, which is what today's topic is all about. And what a Riemann sum is, you basically break this unique area, this irregular shape, into equivalent rectangles, and that's what Riemann sums is kind of about in this section. And so in this problem, Riemann sums, they want us to do it in 4 different subintervals. Okay, so here we're going from 1 to 3 on the x domain. So how do we break this up into 4 parts? It's pretty simple. If we need to make 4 different rectangles, there's going to be rectangles that have a width of 1/2 or 0.5 each. And so I'll just kind of create rectangles of about 0.5. So I can get rid of this now. So here's a rectangle of about 0.5 width. That's the second rectangle, our third rectangle, and our 4th rectangle, right? So you see 4 rectangles, and if I adjust the height, then hey, we're getting closer to the actual value of this area. Okay. Now Riemann created 3 different ways to do this. He said there's a left sum, there's a right sum, and a midpoint sum. And it's pretty simple basically how this works. We're going to focus on the left Riemann sum first. Okay, all it is we create the same exact rectangles, 4 rectangles, but the heights are going to be located in different places. Okay, so for a left Riemann sum, what this means is we look at the left side of the rectangle. So let's just look at this specific rectangle right here. Okay, this blue rectangle. I want to look at the left side of this rectangle, and that is where my height is going to be. Boom. Do you see that? How the left side of the rectangle represents the height, that function, of this function. So for the second rectangle, the left Riemann sum means my left side of the rectangle should be touching the function. There you go, right there. The third one, the left side touches the function. And again, the left side touches my function. Okay, so there you go. There's a left Riemann sum. Now, I'm going to do it again for a right Riemann sum. So here's the same one, but we need to adjust the height. So I'm just going to bring it all up so we don't confuse ourselves. So let's start with this blue first rectangle. Now this time a right Riemann sum is we look at the right side of this rectangle, so the right side, and the right side's height should be matching the function. So right there, okay? So again, for the second rectangle, we look at the right height, and that should match our function. And so on, and so on. Okay, so not too bad. So now let's do our midpoint. So if that's the left and this one is the right, the midpoint would be that when you look right in the middle of each rectangle, that's where your height is going to be. Okay, so I'm going to change this color to maybe green. So you see how now I'm in the middle of this rectangle. So this green line, which is something you don't have to draw, this is going to represent the height. This is the midpoint. So right there, that is where the height of this first rectangle should be. Okay, so I'm not going to draw that anymore, but again, we find the middle of this rectangle's height, which is right around there. For this one is going to be right around here, and this one is going to be right around here. Okay, so there you go. Here are the left, right, and midpoint Riemann sums.